Okay, I think we can start. We will record the session, so if someone is not available, he can watch the presentation later on YouTube. So first some introduction. My name is Holger Schönberger. I'm the lead developer of Allrender. And with me in the presentation, it's Niels.
Hey everyone, good to see you all. I see one familiar face and lots of unfamiliar faces, so welcome. I'm Niels. I am a software developer and I am working with Holger for almost 10 years now. I guess at the 1st of November is our anniversary, so yay! And yeah, I am supervising the cloud development here at rrCloudManager. And today I'm going to join you to show you a little bit of how Cloud Manager works and give you a little, live demonstration. But first, I hand it back over to Holger.
Thanks. So the first question is, why hybrid cloud rendering? The main reason, less costs. It sounds not familiar because cloud costs, but I will explain it later. Then you have less time pressure, flexibility in your hardware, and more flexibility in your time schedule, and you have a failover safety reliability. Usually time is money, but in our production area, time is always a problem. With cloud rendering, you have a very fast speed of provisioning your hardware. You can hyperscale to any computation power. You can switch hardware anytime if you need a GPU render, if you need high memory simulation, fluid simulation, or high core rendering. Then you can just switch the VM type and you could finish all jobs within deadlines. Some examples from usual productions on premise, you don't have to run to the hardware store. I know that from the time I was working in a company, when there was a hardware failure or when we had to meet deadlines, we have been running to the next hardware store and getting just some stuff to fix it. Or if you want to compete for a job and you know it has a very tough deadline or a hardware requirement, then you could not accept the job. But with the cloud, you can ramp up your hardware and still accept the job. So, yeah, then it does not matter if you do overtime, night shifts, or take some caffeine drugs. You cannot finish your render any faster with your hardware on premise because it's limited. And it's better to keep your artists busy than rather having them waiting for a render. I know it myself. We had a deadline on Monday. On Friday, we have seen, okay, it takes until Sunday. On Sunday, oh, it takes until Monday morning 4 a.m. and the client wants to see some results Monday morning. So we had to sleep in the company, and we created another job that waited for all render jobs, and it just played some music really loud. So when the rendering was finished, we all woke up and continued to work. And it's one advantage is that you can directly bill cloud costs to the clients, because clients, I don't know why, but they always think rendering is for free. You have the machines, so why do we have to pay for rendering? If I want to re-render the shot, just click on render and it's done. And if that happens on Friday afternoon, which is usually the time the clients come with some extra wishes, then you have to shift all other jobs on the farm which have been postponed until this deadline, and you get more issues with the next client and this kind of stuff. And you can eliminate all this with the cloud. So what does it mean for studios? First, you can cut costs by not over-provisioning. Then OpEx is better than CapEx because it improves your cash flow. And it does not only improve your cash flow, because every investment has to be considered. Do I need the hardware next month, next year? Can I invest it? And I have a very good example for this OpEx versus CapEx. We have been working on a project for VW, and we knew we cannot handle that job because of the massive amount of geometry of the engine. So we had to buy 2 new machines with the most expensive quadro cards. We had expenses of more than 30,000, and we had to order them 1 month before the project starts. Project took 1 month, and the client did not pay for 2 or 3 months. So we had 5 months without any cashback for our investment. And this does not happen with the cloud, or not in that extreme. You can ramp up and ramp down as production requires. Your hardware administration is outsourced to Azure. You can use faster CPUs or better GPU cards, and office space is not a concern because machines need space. Okay, some applications for the cloud. The cloud has 2 kinds of applications. One is rendering, which we will cover today, and the other one is workstations. There are a lot of companies that rent some machines in the cloud for artists, for freelancers all over the world to let them work on the same project. So what's the hybrid model? There are some cloud providers, full rendering partners, which could render your stuff. You upload your data and they will render it. But if you use a custom plugin, it might not work, or you cannot change the installed software. It's not easy to update, use different Arnold versions and this kind of stuff. And that's why we use the hybrid cloud. The hybrid cloud is directly connected to your render share, and you have the same domain in the cloud and on premise. You have the same render folder, same settings. So if it works on your machine in your company, it will work on the cloud. And the hybrid model will save costs compared to a pure on-premise or a pure cloud render farm. Next topic, the biggest one, the most important one. So this is a typical project. You have a small start with a little bit test rendering. Then you have the main render and the endphase where you have to render fixes or compose some stuff. And if you want to render all stuff within a few hours, you would need a lot of machines, like 100 or 500, which you never have. So what do? You usually clamp it to some amount of machines you can afford, and the project takes more time to render. So this is where the cloud comes in. The cloud should not be used for the whole project. The cloud should only be used for peaks. Typical questions. We have multiple projects, so there's no unused time on the farm. You always have peaks on the farm. And if say you have 100% workload all the time, then I can say the only possible way to achieve this is to shift all projects, so you cannot guarantee any deadlines, or the producer needs to know the exact render times before he applies to the for the project. So you can calculate, okay, this project takes exactly 1 month on the farm, and on the 1st of next month we can take the next project, but this does not happen. So cloud rendering is perhaps not for you. If you can confirm one of these statements, you know exactly what your render times will be for the whole project, you know that rendering is easy and smooth all the time, or your render times have never been higher than expected, your client has never requested more changes than expected, your computers have never break, and you never thought that you might miss a deadline because the render times are too high. And I've never seen a company which could solve all these issues. So cloud rendering is for you. Producers, but now we have to calculate how much time, how much money we will spend on the cloud. But you do the same calculations now, because now you calculate, okay, this project takes 1 month on our render farm, and you just convert that time into costs. But the advantage is you can eliminate the time completely, because you can use one machine for 10 days or 10 machines for 1 day. The costs are the same. The calculation is the same. So that's not an issue. Next, our on-premise machines are for free, but cloud costs every minute. The cloud costs, but only if you use it. And is your hardware really for free? Many companies buy new machines after 3 or 4 years. So, and you often forget additional costs. Power, you need room and space, your network infrastructure, you need system administrator, you need air conditioning, and you have downtime if your machine breaks. And the larger your render farm gets, the larger are these costs to maintain. So let's say you buy 40 new machines. They are for free. Let's take 100. They are for free. Why not 400 machines? They are for free. And as you might know, just ask your producer, okay, I want to buy 400 machines because they are for free. As you can see, they are not for free. The main difference is the on-premise machines cost if they are not used. So if I take this example, let's say you need only 100 machines for all your jobs, but you have bought 400, then these additional 300 that you will never use are expenses that you should not have taken. So your on-premise machines cost if they are not used. If you want to expand on-premise, you have, of course, to buy your hardware. You have to take into account the electricity consumption. Do you have enough room for all the hardware? I know a company in Munich, visual effects company, they had to spread all their computer racks all over the floor and they put some computers into the basement of the building, and he asked me to touch their main power line, and the main power line was really getting warm. So the building was at its limits, and you cannot handle as many machines as you would like to have at some time. And what about your network infrastructure? It's not just some cables and switch. Do your file server can handle that many new machines? And at some time, you need some hardware administrator or service, and you need a lot of air conditioning the more machines you order. On the other side, the cloud has some discounts. So there are spot prices because the cloud providers have the same issue as you have. Machines that are not used cost money. So what do? They offer these machines that are not rented for spot price. They offer machines that they have in reserve for hardware failures for the same spot price, and you get a 60% discount on AWS and Google, and 86% discount on Microsoft Azure for Linux machines. And for Windows machines, the discount is not that high because you don't get a discount on the Windows license. But if you have your own Windows licenses for your network, you can often use these Windows licenses on the cloud VMs as well. In addition, they offer saving plans. These companies just like to plan like you do, and they offer you 30% for if you want if you guarantee them, okay, I want to use this kind of VM for these many hours, they offer you 30% for 1 year. If you tell them, okay, I want to use this amount of hours for 3 years, they offer you 50% discount. So about the cloud saves costs. Okay, if I'm running the whole month, then your on-premise machine is usually cheaper than a cloud machine. But if you're running just 10 to 15 days a month, then you're at the same price. And if you're running even less days in the cloud just for the peaks, the cloud gets cheaper than your machines. For this graph, I've used the spot VMs and I've used Linux. And for most applications, Wallrender offers a path conversion. So if you have a Maya scene, you can just submit it to Wallrender on a Linux machine, and Wallrender will convert all paths in your scene file to Linux. So it does not matter if your main operating system is Windows. You can just render on Linux to save costs. And in this example, I've not taken into account the air conditioning room and network administrating and the artist wait time. Because if your artist has to wait for render, his wage is way more than a few cloud VMs rendering. Let's take a look at some numbers. So if you buy for example, if you buy, for example, a render cube rack with 32 cores, which means 64 hyperthreading cores, it costs you €9,000. If you build such a machine yourself, €6,500, but then you have no guarantee if there's a hardware failure, the machine is lost. The prices include in electricity consumption for 360 days. That's either 1 year or 3 years, 10 days a month. Office space and network infrastructure is also not included. And on the other side, we have the costs on the cloud. If I take a machine on Azure with spot prices, it costs 3,200. This one costs 8,000, and this one costs about 6,000. So you can see if I buy a machine for 3 years and use it only 10 days a month, then the cloud might be cheaper. For Azure, it's definitely cheaper. AWS is cheaper than any pre-built system, and Google is about the same price as a self-built machine. So if you're so you can compare if I use for example the cloud for only 5 days a month, then you can use your on-premise machine for 6 years or the cloud for 6 years, and the cloud is still cheaper. So let's start with Wallrender. Niels?
Okay, so I guess it's my turn now. So yeah, getting started with Wallrender in the cloud. And wait, okay, now. So there's a lot of ground to cover if you want to start with cloud rendering from scratch. So you have to care about your provider account. You want to have a virtual network. You want to secure your network connection. You want to create your VMs. You have to care about routing, SSHing, RDPing into your virtual machines. and so on and so forth. So there is maybe there are a lot of rabbit holes you can walk down to, and we thought maybe we should help you with a tool which simplifies and automates most of these tasks. And we did, and that is our Cloud Manager. So the Cloud Manager takes care about most of these aspects. It creates your virtual network, it secures your network connection, aka it creates your open VPN tunnel. You can choose your VM types, your VM images, and so on and so forth. There are a couple of things yet that you still have to do manually, but I would say you have to do it either way. You have to be you need to care about your routing on site depending on how your network topology is. You have to have a file server, and you have to make sure that your data is transferred into the cloud so the cloud clients can access all the data. And optionally, but most of the time, you will want to create your custom VM images. I mean, what we do is we provide pre-configured VM images for the big three cloud providers, as they are Azure, AWS, and Google Cloud. But we cannot take all those different aspects into account. So you might want to use that as a starting point for your custom images. Okay, so now we have the Cloud Manager, but what exactly is the Cloud Manager? As I said, it does a lot of administration work, like creating your network resources, creating VM resources, connect to your VMs. Behind the curtains, it acts as a sort of proxy to communicate between server and your clients. But the main component of the Cloud Manager is the Cloud Connector. And you can think of the Cloud Connector as a set of parameters and functionalities for let's say 10 cloud clients, cloud VMs with the same characteristics. So you choose, for example, the cloud provider, and the cloud provider could be, for example, Azure at a location, maybe West Europe, or it could be, let's say that is the cloud provider. Then you choose one VM type, one VM image. Let's say it's Windows Server 2019. And that defines your cloud connector and the amount of machines that should be running in that cloud connector. And you cannot only have one cloud connector, you can also have multiple cloud connectors. Why would you want to have that? I mean, the reason is just versatility. You can, for example, have one cloud connector that only has Windows machines with GPU support, and then you might want to have another cloud connector that has just a CPU enabled VM types, and so on and so forth. You can structure. You can have more sets with different configuration. And remember, one cloud connector has all the parameters that are set in one cloud connector apply to all the cloud machines that are running in that cloud connector. Okay, so, and what is the modus operandi of the cloud connector then? So first we have to choose the number of VMs to create /start. And first we choose a global VM limit per cloud connector. That is sort of a security measure, because you don't want to spin up accidentally hundreds of machines that are costing you money and you don't need them. So that is the ground truth. You never get more than that. So be careful when you set that number. You then have two operation modes. Like the first one is the auto mode. So the number of VMs that shall be used on that cloud connector will be calculated by the Royal Render server. And this number is then transferred to the cloud manager, and then the cloud manager will spin up this number of machines. And you can also do the manual way. You are the admin, you set the number of machines to create or start. And then when you want to render a job, machines are going to be created / started. And if you are starting them the first time, or you change anything in the configuration, our companion app, which is running on all the cloud clients, will configure that virtual machine. It is called Cloud Service. And it receives just a package of configuration, and then configures that virtual machine accordingly. So it sets the domain, the time zone firewall, mounts your shares, and so on and so forth. And then your job is rendered. And I mean, that is, again, working behind the curtain, so you don't see that at all. But the Cloud Connector acts as a proxy to communicate from and back to the server. And then your job is rendered as it would be rendered on-premise in your normal setup. Your job is done, and then your machines have to be shut down. And then we have 3 modes, how that works. First, we have the auto mode. So if your machines are idle, or the server decides that the server does not need any of those machines anymore, they will be shut down automatically. We have a second mode, which is the manual mode. So the admin can reduce the number of VMs during operation, which means maybe if you started with 10 machines and you just reduce the number of machines needed, let's say to 5, obviously 5 will be shut down. Or you can completely deactivate the Cloud Connector, so that stops everything immediately. Your machines will be deallocated, and you won't have to pay any more for them. Okay, so, and before we go to the live demo, I want to quickly show you the network topology, if you will, the network structure of our setup, of the hybrid setup. So the left side you see here is the on-premise, the local network. You have the raw render server, as you might probably have already. Then you have your SMB/NFS share, where all of your data resides in. So your scenes, your textures, and so on and so forth. And you have your local render clients. And additionally, you have one machine that is running the Cloud Manager and is running the VPN client. I mean, we do that just for convenience on one machine. You could split that up if you want or need to. And on the right side, we have the cloud, the virtual network part of the hybrid render solutions. We have the VPN server that connects, or the client connects to the VPN server, creates a VPN tunnel that is secured, and all the data will be going through the VPN tunnel, and it would feel like if everything would be on premise. You have the additional caching server just to reduce the amount of traffic that will be put on the VPN tunnel. And then you have your cloud render clients here on the right side. So that is the network structure. Pretty easy. And then I think we can move over to the live demo. So maybe we can just move on to... Oh, can we stop the presentation quickly? Okay, thank you. And then we can move over to the Cloud Manager. So that is the Cloud Manager. And first, I want to show you some of those settings that we covered before. For this demonstration, I'd like to use, or on the left side, you see the cloud provider. So first you have to configure your cloud provider. In this case, it's the Azure cloud provider. You just have to copy your credentials here from your Azure portal or whatever provider you use. It's mostly 3 to 4 values. Then you're able to access the API. So choose the cloud location and so on and so forth. You can almost go with the default values everywhere here. The only thing that is truly important is the local network IP range, because you maybe have a different IP range here. You choose the VPN VM size. The image is a predefined one from us. You can just use that. And then one or two more important settings are the settings where the Royal Render root is, and where you have your additional separate share. For us, it's the Royal server at this IP address. And then we can create and use our cloud connectors, and we choose to use the Azure Win cloud connector, which is obviously a Windows image used here. We can select the cloud provider, which is Azure. This is this one on the left side here. We set it to a maximum of 4 VMs. We can decide whether low priority or not. Low priority is another word for spot VMs. Holger told you before. Then we can choose the VM size. And the good thing is that I want to quickly show you is you can load the available VM sizes. Then this drop-down box is updated, and you can click on that, and you see how many cores and how much RAM this particular machine has. We go with this one. We have Windows operating system, and then another important thing is which VM image you want to use. And we have a couple of predefined ones here. You can browse through them like this. We have Linux, we have Windows Server, and so on and so forth with CUDA and grid drivers. You can always use those as a starting point for your own custom ones. Okay, so, and that is basically it. You can close the settings here, and then we want to work with the CloudManager. First thing is you have to press the connect button, and the connect button just connects with all the APIs from all the cloud connectors that are available. These are the tabs for the cloud connectors that we defined before. We're going to use the Azure Win one. As you see, we receive the API status, the power status of all the machines. At the moment, it is deallocated, so that's exactly what we want because we're not rendering at the moment, and so we don't want to pay any money. And these are the settings that I told you before. The VM creation and starting and stopping are both set to auto. You could also go with a manual mode, but we stick to the auto mode because we don't have to care about that. We can click on activate connector. So now the connector is activated. Nothing happened so far because we are not rendering yet. And in order to do that, we obviously have to submit a job. So we prepared one here for you. And it is just a Blender scene. It is, I think it's a splash screen from the from a previous Blender version. Yeah, its name is Cozy Kitchen, and we defined a image directory. And we assign this job only to our Azure Win cloud connector here. So this is exactly that. It's Azure Win here, and it is Azure Win here. So you see green, this one is assigned. And then we can just submit this job. We can keep the submitter open. And then we already see, okay, we now have a job pending here, and therefore we get a number from the server, the machines the server would like to see here in our cloud. And they are starting right now. And I think now we can wait a little bit until we see more happening here. It takes obviously a bit before they are running, and maybe if you have any questions so far, we can answer them, hopefully.
Will this also show up in the RR control somehow?
Oh yes, we can do that. We can open the RR control in parallel. So as you see, the new job pops up here. And I think we have an old one pending here, but I mean, this is not assigned, I guess, or we can just quickly deassign this one. And this is the new job with the 24. Right? Okay. Yeah, so it's shown here, and everything that will happen in the cloud will be shown here the same as it would be shown on an on-premise job.
Nice. So that includes job log and everything we may be interested in for debugging.
Yeah, of course. I think we can just wait a little bit, and then Holger can pop in a little later, so we can walk through the rendered images and see what the log says, and so on and so forth.
Cool. Maybe one more question that we realized when trying to render in the cloud, that getting our hands on GPU instances was always a bit hard. With Amazon, we always have to apply for increased quota to be allowed to even try to run them, and then we never know if we really get them. Do you have any experience with that? That after some time, this will eventually just work? Like, can you easily scale to 1,000 instances, or is that something that they typically limit, and you need to be, I don't know, Volkswagen to run more machines?
It depends on the provider and the region. For example, for Azure, if you try to get GPUs in Amsterdam, it's really hard to get a lot of VMs in Amsterdam. But if you change the region, for example, to new data centers like Sweden or Finland, then you can easily or more easily get GPUs.
Okay,
But
that's a good point. That probably because bigger companies are already configured to use the existing data centers, switching to a new one may have more resources lying around.
yes, and some companies think, okay, Amsterdam is closer, so it's better, it's faster, but usually there's not a huge difference if you are in Sweden or Ireland or Amsterdam. It doesn't matter. Perhaps USA has a little bit of lag, but it's not about real time. If the client gets a command to render an image in 1 second, or if it gets a command in half a second, we don't care.
Mm-hmm.
We are not using the GPUs for real time applications where where you need a direct feedback.
Yeah, that makes sense. And one other question that I have is, how are you managing licenses? Are you forwarding licenses from the office through the VPN connection, and we just have to make sure that we have enough? Or do you have some usage-based license model that Roll Render could help with?
We can. I will just continue with with the presentation. As you can see, we have the 4 clients. The VMs are running, and the client is running as well. And once the client is running, you will see the status of the client in control. So challenges, licenses. So there are 2 license models. Buy your own license. You have the same costs if you will use them or not, and you are limited to the number of VMs you can start. There are the typical yearly subscriptions, but there are rented licenses as well, so you can rent a license for a month. And I would recommend the yearly or rented subscription. On the other side, there are metered licenses. You pay only what you use. There are prepaid license or postpaid licenses. Render uses a prepaid license. Postpaid licenses have been available for all Autodesk products. They have been available for V-Ray, but so far I don't see any information on these cloud metered licenses anymore. It's probably because if a company uses the cloud, then they will not use it for 1 day in a year. They might use it for 30 days in a year or for 50 days in a year, and then these metered licenses have been more expensive than the monthly or yearly subscription. And that's why most companies are using the rented license or directly yearly subscription. For example, a V-Ray license for a month cost, I think, €30, something like that. So we don't offer licenses for the renderer. You have to get licenses by their vendor itself. So from Autodesk, from KS Group or Maxer. Next challenge, data transfer. Of course, you can use your on-premise file server, but then all textures are transferred once for every VM, because every VM reads the texture, and for every frame again. And that's very, very slow, and you pay for VMs waiting for files, and are recommended for a test setup only. Then, of course, you could copy your files to a file server, but we don't recommend that because you miss files, or if you update a file, it's missing, and don't use any copy command. And the recommended way to do is it's an automatic file transfer. There are two different kinds of solutions. One copies all files, but that requires a huge space in the cloud if it just synchronizes the whole project folder. And often these solutions have no file metadata presync. Metadata presync is a way if you save a file, then this file is displayed on the other file server within a few seconds, but the data is not yet transferred. And you want to have this presync of the metadata, so you directly know if there's a file or not. And if these copy solutions just copy one file after another, and if you're rendering 1,000 files and you want to know if and then some important file is saved, then you have to wait for these 1,000 rendered files, and then your reported file is copied. So these are not a good solution as well. And the other way is synchronize on demand. This means the files are listed, the metadata, as I said. And if you open a file, then the file server loads the file and transfers it to your computer. And there are simple tools which are never intended for this use case. There are add-ons for your existing file server, and you can replace your file server. So simple tools, for at first our requirements for that we have used to test it. The solution has to run on a file server, and this file server serves for multiple clients. You don't want to install this solution on each client, because then you have the same issue again, that each client copies the files. You want these metadata presync, that we directly see if new file exists. Copy on demand, only if we need the file, the data is transferred, and it has to be reliable. So the simple tools are these Dropbox, Nextcloud, Ting, and they all failed They are intended to run on each machine and not on a file server, and they are not intended for this huge amount of data. Then there are some add-ons. Niels, would you like to introduce yours first?
Yeah, just switch on my microphone. Yeah, because we tried to find a solution that works for us, and we didn't find a real solution, and there were some abandoned GitHub repositories that were trying to do what we wanted. So I decided I use libfuse, which is exactly which is a virtual file system, if you will, file system library for Linux, and I used that to build some sort of sync on demand service for that. So if you want to use that, we can share the GitHub repository with you. It's still in early development, but it works as expected. So you can use it with Zamba, and you can use it with network file system, NFS. Yeah, so there's a little bit of manual work involved, but I mean, yeah, it is a good start, and maybe in the near future we will have one or two button-click solution to deploy a Fuse cache server then for Royal Render Cloud. Yeah.
A different solution is Resilio Connect. We have a big customer which is using it, and they are happy so far. It's an add-on for your Windows or Linux file servers, and you have a lot of settings, and you can control it, which files are automatically transferred, which are only synced on demand, and it's a really good solution. And you don't need to reinstall your file servers. The last option is a complete replacement of your file server. So there are commercial solutions like Hammerspace or Pixcache, and they install the server for you. You tell them how many how many file servers you need, and you replace your whole file server with the system, so you can use it in your company as well. If you have, for example, 50 or 100 machines, you can install 2 Hammerspace or 2 Pixcache servers in your company, and then more in the cloud. And about these, and then there are some open source solutions which we have not tested, but they are used in production as well. If you create a file server in the cloud, it depends, of course, how many machines, how many clients do you want to use. We recommend that you create one file server for a maximum of 50 VMs, perhaps less. So if you want to use more clients in the cloud, you have to create multiple file servers in the cloud, and one file server is responsible for a small amount of clients. Another aspect is security. There are some companies which have to go under investigation if they are secure. You have to that you will have an audit if your network is secure, and let me assure, they all approve cloud rendering. So I'll show you how the typical network structure works. So the typical security. If your company is restricted, then you have your main work area with the file server, render server, and license server. Then you have a firewall, if at all, or just no connection. And in this area, you have email stations and the cloud manager, and they are free to connect to the internet. Then you have the cloud, the wide open internet. And a lot of people think, oh, the cloud is not secure, and what's about my data? But that's why we use a VPN, and the data center itself is secured as well. So you have your the cloud manager could start OpenVPN, or you use your router or a switch on your own VPN server. On the other side, you have a VPN gateway as well, and they connect. And this data is secure, so no one can intercept your data and decrypt it. So it's not a problem to render in the cloud if you if you are under restrictions. At last, some notes. There are a few things to consider in advance. So if you want to render tomorrow, then I would say it's not enough time, because you have to register. Then you might want to choose or decide which region or data center do I want to use. There are regions where the electricity is cheaper. There are regions where the electricity is green. For example, Norway or Finland, they have a lot of water power, and it's usually colder, so they need less air conditioning. Ireland is cheaper, and Amsterdam or London are more expensive, for example. Then, main issue, quota. Cloud providers restrict you in the maximum number of VMs you can start. They do that for two reasons. They have to plan how many VMs can be used, and the other thing is they don't know if you can pay 100 or 1000 VMs. That's why they have this quota restrictions. The restriction is per type. So if you want to render on GPUs, you have request quotas. If you want to render with slow CPUs, that's another request. If you want to have fast CPUs, that's another request. So you should request them in advance. If you consider to render in a few months on the cloud, just try to request them now. Sometimes the quota is approved on your previous usage. That's for Google. So if you have used 10 VMs in the past, then you can automatically increase them to 20. If you just if you are new to the cloud, then there's usually a manual approval. So I just requested 1,000 machines 1 week after I joined the cloud provider, and then I got an audit, and they called me. I had to validate my business, that I am a business and not a person. And sometimes they want to have some proof on your business volume. So if your company has a lot of cash flow, then you can order more VMs. And that's the most important part. If you want to render in the cloud, get your quota in advance. So when you need a lot of machines, you can increase it. So let's take a look. Yes, you can take over.
Microphone on again. Okay, so I think we are almost done with the job here. So yeah, so most of the machines are shut down already. Then you can see the job results here, view, and you see everything has been rendered. It's just 25 frames here. And yeah, the machines has been automatically shut down. And I think I'm happy with my rendering. Okay, do you want to go into some more of the details with the log files maybe?
I think your mic is still muted, Holger, in case you're talking.
Yep. Thanks. Okay. As you can see, it's hybrid rendering, and so it's exactly the same as on premise. You have the same environment. For example, we use Blender, and Blender was not installed on the machine. We have set up Blender as shared executable in rrender, and the client has copied Blender automatically as it would do on premise. Same environment, same log file. So that's the advantage of hybrid rendering. It's not a separated system. You don't have to retest your plugins. If your plugins work on premise, they will work on the cloud. The only exception is if you switch the operating system to Linux and you're using custom plugins, then you need to provide the same plugin. For example, if you're using Arnold for Houdini, then you have to provide the Arnold version into rrender, one Linux version and one Windows version. So it can be used on both operating systems. Okay, any more questions?
I actually have one more on licensing. You mentioned that metered licensing can be offered postpaid. That's probably very dependent on each software manufacturer and what they offer. Do you have any experience with, I don't know, basically meta services that you apply once and then you can choose from licenses for Houdini, Cinema 4D, Arnold, Redshift, Octane, whatever, to have one endpoint that your licenses go through, or are clients typically setting up each of them separately and configuring this based on every provider?
It depends on the license provider. But usually, if you're using this metered licensing, then you have to open one port in your firewall to this external license server.
Okay.
And you have two options: either open the port in the cloud, but usually you don't do that. So you open the port in your company, and all license requests are going through the VPN to your company, and then out of your company, because it's easier to set up. You can test it on premise, and then once it works with the floating license, with the metered license, you can use it in the cloud the same way.
Okay.
Hi, Holger, it's Tim. I'm sorry I missed the beginning. Does rrender support like just the big three, I guess, cloud providers? Or if we want to use another service, is that possible? Or like you mentioned Azure.
Yeah, as so far we have built these plugins for these three cloud providers.
Okay.
We offer, we are using a Python library, and it's possible to add a plugin for a custom cloud provider there as well.
Okay. I assume that means work for you, of course. But okay, I understand. But for the time being, Azure should work fine. Amazon and Google, right?
Yeah.
Okay. And in terms of the storage, and you spoke about the VPN server, does the VPN server have to be running all the time or on the cloud? And how does that work? Like to establish a connection to whatever
the VPN server has to run, the VPN server and the file server.
File server are always running. Yeah. Okay.
And of course, you can shut them down if you're not rendering on the cloud.
Sure, that makes sense. Okay, thank you.
But you can use cheaper machines for.
Oh, that too, yeah. And I guess, I mean, depending what you're rendering, if the file server is closer to where the data center is, I'm sure that'll have an impact on how fast the renders will be. But I guess that's for us to manage as well.
It's the data transfer. There's the farther away the data center is, the more latency you have. So
yeah, exactly.
it takes more time for the package to get there. but usually the speed is very high nowadays. So you have to wait a little bit more time, a few seconds or a second to initialize the transfer. But once the transfer is running, it's usually fast enough.
Yours well. Okay. Thank you.
Most of the time, the limit is the connection on your side.
Yeah, sure.
Your internet
everyone.
connection usually is the slowest point.
Yeah, I would imagine. Yeah. Thank you.
And for rendering, it's the rendering is fast enough. You have to wait until the data is transferred back, of course, and that might take some time. But usually that's faster because your download speed in the company is higher than the upload speed.
Yeah. Yeah. Have you done any simulations or like where you're rendering a lot of data where involves simulations like cloud particles or stuff like that? Have you seen any tests with that or?
Yes, but then I recommend to separate. For example, if you want to simulate and render the data, then you could do all the stuff in the cloud, and your on-premise file server will never download the cache files.
Sure.
So because if you don't request the cache files, you can exclude them from the automatic download. Then all this huge data is in the cloud. You simulate it in the cloud, you render it in the cloud, and it does not affect it does not produce any traffic to the VPN to your company.
Got it. But you still have to be aware of that, I guess. But yeah, when you're all this. Thank you.
I have also one more question about this data syncing and file transfer stuff. I'm not sure if I completely understood it correctly, but this is basically already kind of implemented because you talked about these different tools, right? These syncing tools and everything.
No, it's not implemented. We're just controlling the VMs, but you have to set up the data transfer. We have tested some solutions, and Niels has created a solution, but that's up to you to install the solution, because it really depends. We have one customer; they are using 400 VMs, and they decided to use Hammer Space, other one PixCache, a smaller. Not really small. They have, I think, 100 or 150 VMs. They decided to use Resilio Connect, and they're not using it only for not only using it for the cloud. They have different offices, and they are sharing data between their offices with that solution as well. And of course, these commercial solutions have price. They're not for free.
Okay. So
Yeah,
basically,
if you like, I can give you the GitHub repository for the Fuse Cache solution. And yeah, I mean, if you have any questions regarding that, we can always help you. So, but it depends. I would say it depends on how many clients you are planning to use. So if you want to use a huge amount, we haven't tested that so far. So yeah.
So basically, I can install Royal Render. I can easily create this connection to the cloud providers. I can easily give them an image that I want to spin up. It automatically, creates those clients. But essentially, when I'm now thinking I'm in Houdini, I'm using the render submitter, the Royal Render submitter, and I send it to those cloud clients. I still have to take care about somehow in this process. I need to either send the files to this cloud file server, or I don't know, set up whatever technical solution would work for us.
Yes, for a simple test, you can use the on-premise file server, but as said, it's slow because it's limited by your internet connection, and then you should install a file server in the cloud and set it up that it will transfer all data. And once you have set up the file server, you can use this for any project.
Okay, makes sense.
shut down, so we can turn it up it again. Message up.
Did the VN shut down on their own?
Yes.
Yes.
They did.
And you were mentioning some sort of, maybe I also misheard that, but some sort of auto downloading of output files.
That's
Did I miss?
synchronization. What's the file server solution?
That would be the, yeah.
No, it's so these automatic file sync solutions. They should be installed on both sides.
Right.
You could install them on one side, but then you have to copy them manually. But all these solutions work with an installation on both sides, which is why these are more complicated, because in this case you need to replace your file server in your company. With these add-ons, you don't need to replace the file server. You can just install it on top. I've increased the frames and they're starting again. And as you can see, we have the automatic mode enabled. Oh, you don't see the mouse cursor. Anyway, no. Okay, any other questions? Oh yeah, one important thing is, of course, which VM should I choose? That's another question. And what we have started, we have a benchmark on GitHub, and this benchmark executes Blender, Arnold, V-Ray, and Max on Cinebench. We have a GPU test as well, which uses Blender and V-Ray and Octane. And we're about to run this benchmark on all machines, on all machine types. You can download and run the benchmark on your machines. And we will provide an application, not in short time, but perhaps this year, that you can compare the render times easily. So you can see, okay, this machine on the cloud will render twice as fast or with half the speed of my local machine. And this way you can choose the right machines you want to spin up in the cloud. Because there are a lot of different VM types. As you can see, these are the Azure VM types, only a part of the VM types which we have selected for usage, and the same amount of VM types are available on AWS and Google, and it's sometimes complicated to choose the right one and which one has the best cost performance.
Have you evaluated that, or
Pardon?
have you evaluated the cost performance? Because they could say I have 128 cores and whatever amount of RAM, but in reality, they're not as fast from one provider to another.
No, as I said, we are starting it. We have this benchmark, and we have executed the benchmark on Azure so far.
Yeah,
and now we have some numbers how fast these machines are.
Sure, it'd be interesting to see in terms of price as well. You know,
Yeah, and the next step is that we build an application which is able to load this benchmark and the prices of your region. and then you can sort by performance.
Yeah.
Performance percent or performance per.
Oh, tester. Wow.
And that's the next step. And then you can compare different cloud providers because some they're all using different CPU types. Amazon is using their own ARM processors. Azure is using some Intel and some Epic AMD machines. And you can see these are the different types of processors used. They have an information on the website which CPU type is used for which VM type, and you can use some website like Monkey.
To figure out what that processor is. Yeah. You said Amazon uses ARM processors. Is that correct?
Yes.
ARM. So it's a completely different. It's no longer x86. It's
last time. All
right.
Where was the comparison? So powered by AVS Graviton.
Wow.
64-bit ARM Neoverse. And you don't find any benchmark or little benchmarks on this kind of processors. So
I'm just surprised it can run x86 code on an ARM processor. I mean, there's some sort of emulation going on there, but wow.
Yeah. And that's why we want to complete this benchmark.
Speeds, sure.
Yes. And as I said, it's already available on GitHub, and you can run it on your farm, and you get an Excel table. Now you get this CSV table, and you can import it into Excel and compare your machines.
Great, thank you.
We have a GPU and a CPU test. We use it as well if, for example, if we change BIOS settings, there are some TPD reduction to reduce the power amount, but do we still get more speed if we increase the TPD? Do we get more speed if we change the megahertz of the one?
Yeah, memory timings and whatever.
This kind of stuff that's we use it for that as well. And so far, I can tell you it doesn't matter a lot if you change the one speed.
I think most people would just want it to be reliable more than anything else. I don't think they'll.
Yeah, the new DIMMs have some option for optimized settings. You can load the optimized settings. But as I mentioned, it doesn't matter a lot for rendering.
What raw render version do we need to install to play around with these cloud tools? And is it already like released? And
it's already released. We have a version. So of course the latest version is 9.1. And the CloudManager is available in 9.0, but it's not the latest version. We have Niels has done some optimizations, bug fixes, but I think any version from 9.1 can be used, and it's should be compatible. So if you're using 9.10, we can get you the latest CloudManager and should be compatible with your all-rounder version. Then there is the calculation that the server does. The amount of VMs that should be started is calculated in this client need factor. Now if I disable the job, so it's 0 now. And the server calculates it on the sequence length and your sequence divide settings. So if I would change it to 50, a maximum number of 2 VMs would be started. 10, a maximum number of 10 VMs would be started. And the cloud manager receives, always receives settings for each cloud connector, how many VMs it should start. So if I'm assigning one job to one cloud connector and the other job to a different one, they all start different amount of VMs. Any questions about any of these pages? I think that the most important part is to understand the price difference. So if I'm not using the cloud all the time, it's cheaper. As you can see in this example, the Azure Spot VMs are, they have the most discount of all providers, but they are more they're not that easy to get in some regions because a lot of companies have assigned for this savings plan, and they already guarantee, okay, we want to use their Spot VMs for 3 years and this amount of hours, and so they're already reserved. Yeah.
Holger, would it be possible to get a copy of this PowerPoint? I know there may be some information on here that's sensitive, or you want to keep for yourselves, but
no, I'm recording the session, and we will upload it to YouTube.
Perfect, thank you.
And I think if you all agree, I will not cut your voice out. It's a presentation and the voice of all attendees will be recorded. Okay, so if there are no more questions, then we are done for today, I would say.
Thanks so much for your time, Holger. Much appreciated.
Thank you so
Yeah,
much
thank you.
for joining us.
Then enjoy your afternoon. Bye bye.
Bye bye.
You, thanks. Bye bye.